Okay, this is the P1 paper from January 2023. It's question number 5, and we can see the first part of the question is going to be using index laws. The second part of the question, we're going to be solving a quadratic. Let's read it through. It says, by substituting p equals 3 to the x here, can we show that this equation can be rewritten as that equation there? Yep, we can certainly try and do that. Let's make a start then. So first of all, let's just write out the equation. We've got 3 multiplied by 9 to the x, and then we've got 3 to the x plus 2, and we've got 1 plus 3 to the x minus 1. So remember, we want everything to be in terms of 3 to the x here. So if I'm looking at this first term here, this 9, all I can do with that is say, well, I want it in terms of 3s, so I can change 9 to be 3 squared, to the x, plus here, 3 to the x plus 2, I can break that down into 3 to the x multiplied by 3 to the 2, and then with the third, the term on the right-hand side here, 3 to the x minus 1 is 3 to the x times 3 to the minus 1. So it just depends on how many steps you want to do all in the same go. Here, what I'm going to do is I'm going to call this 3 to the 2x. If you multiply, so if you have a situation where you've got something raised to the power there, we multiply the powers out. With the 3 to the x 3 squared, I can call that 9 lots of 3 to the x. Remember, we want everything in terms of 3 to the x. And here equals 1 plus, and then this is 3 to the x divided by 3. So the only thing now that I haven't got in terms of 3 to the x is this one over here on the left-hand side. And you can do that by saying, okay, yeah, this is 3. What I can do now is call this 3 to the x to the 2 here. Look at the difference between these two. You could have swapped them straight over if you wanted to, but I wanted to explain what I'm doing. Plus 9, 3 to the x is equal to 1 plus 3 to the x over 3. And then if we make the substitution that p is equal to 3 to the x now, if p is equal to 3 to the x, I'm actually going to get 3 lots of p squared. 9 lots of p is equal to 1 plus 3 over p. Okay, at that situation there, let's just multiply everything by 3. Oops, sorry, I was just looking at that. I'm wondering what I've done wrong here. That's p over 3, isn't it? Not 3 over p. That would make it slightly more difficult. Yeah, multiply everything by 3 at this stage. We're going to get 9p squared. 27p is equal to 3 plus p. And then just take everything over. So we're going to get 9p squared plus 26p minus 3 is equal to 0, which is the first part and what we wanted. For part B then, part B says, can we solve the equation? So if we're solving this equation, we're solving this equation. And I'm going to show you, I won't keep it all in my answer, but I'm going to show you how to do this factorising then. So 9p squared plus 26p minus 3 equals 0. Some of you will be able to just almost do this by inspection. And you could say, for example, 9p is here and p is here. And then you just play around with the numbers and eventually we get that coming out. But I will show you a slower way of doing it, just saying that if I was doing it, I'd try and do it really quickly in my head there and just have a quick play around. If you can't get that, you could always use the quadratic formula, or you can use what you guys will call the AC method, which I'll do over here. I'll do it in red and then just get rid of it in a second. If I've got 9p squared plus 26p minus 3 and I'm trying to factorise it, the AC method says here's A and here's C. If you multiply those two together, you get minus 27. And so what you're looking for is two numbers that multiplies together to make minus 27, but that adds together to make whatever that middle number there is, in this case, 26. So the two numbers in that case that are going to multiply together to make minus 27, but add together to make 26 are going to be 27 and minus 1. Excuse me. Well, if I've got those two numbers, all we do now is we replace our 26 with 27 and minus 1. So we would have 9p squared plus 27p minus p, oops, not minus 3, minus 3 there. So when we're looking at it, this thing here has just been replaced by those two. Once you've done that then, looking at the left-hand side, we can take 9p as a factor out of the first two terms, and we'll be left with p plus 3. That means I need to have p plus 3 in this second bracket here. So in this case, that's a matter of taking minus 1 out, and then that gives me 9p minus 1, p plus 3. And so that's what we had up there, but by doing it by inspection rather than doing the AC method. So, yep, you can do that if you want to. I'm going to get rid of all that. I don't need that as part of my answer. No problem with doing that if it means that you're going to get these answers right and it's a little bit slower. By all means, just try and get more complete answers than racing things through and making mistakes. At this stage, if we do have that, we say p works out to be equal to a ninth, or p works out to be equal to minus 3. Now, just remember the question said, can we solve this equation, not that one there? So if we're going to try and solve that equation, what we have to now say is, okay, 3 to the x is equal to a ninth, or 3 to the x is equal to minus 3. And this is where we would rely on you having some decent skills here. If 3 to the x is equal to a ninth, then that's the same as 3 to the minus 2 is equal to a ninth, isn't it? Because 3 to the minus 2 is 1 over 3 squared. So here, just by looking at the answer, we can see we get x equals minus 2 there. And 3 to the x equaling a negative, 3 to the x can't be a negative, so that one there is going to give me no solutions at all for that second part. So that's the question, some index law work and some quadratics. Hopefully that all makes sense to you.